if the materials reaches in the plastic zone, and it can be if the stress developed or induced within the material is more than that of the allowable stress. So if any case happens, then we will consider that it is as a theory, as a failure of the material. Now, there are some theory to estimate the when or the for the particular stress, okay, when the failure will occur. So if I discuss the first theory, the maximum principal stress theory. Maximum principal stress, you keep writing theory. Then what happens? You know that from the first conditions of the thick pressure vessels, we have developed a relationship like this. That is nothing but the hoop stress at Ri. Okay, hoop stress at Ri, it is Pi Ri square. Okay, from the case 1, Pi Ri square R naught square minus Ri square multiplied by Ri square plus naught square divided by Ri square. Okay, so if you can recollect this formula, so hoop stress at internal radius, it is become like this, and we can also write this as Ri square will be cancel out, so it will be R naught square plus Ri square divided by R naught square into Pi, or therefore you can write the internal pressure to the hoop stress, it is equal to, it will be R naught square minus Ri square, R naught square plus Ri square equal to a square minus 1, a square plus 1, where a equal to naught by Ri. And this relationship is known as the maximum principal stress theory. Okay. So this is known as the maximum principal stress theory. Now, you see here, these equations has a limitations. The limitation is this: it does not include the Poisson's ratio. Poisson's ratio means the stress by strain ratio. Okay, where we know for the material behaviors under the load, there is a relationship between its stress induced to its strain. So this equation does not include that Poisson's ratio, which could be the indicative for the plastic deformation. So the limitation is this equation, you keep writing, okay, it or this relationship, this failure theory, it does not include Poisson's ratio. Poisson's ratio, that is mu. It is noted that, or it is reported that the failure theory equations which incorporate or which contains this Poisson's ratio gives better understanding with the experimental value. So this theory has these severe limitations. Now, the second theory is the maximum strain theory. Maximum strain theory. According to this theory, the material will fail or the failure will occur. Failure will occur when the strain setup in the material reaches the strain at elastic limit. At elastic limit by the induced stress. Now, the equation for estimation the thickness corresponding to the failure of the material according to this theory is that this is the hoop stress maximum. Okay, so the maximum hoop stress is equal to, okay, this should be the yield stress, this should be divided by the factor of safety, definitely, equal to pressure into 1 minus mu plus one plus mu into k square. K is nothing but r naught by ri, or d naught by di, whole divided by k square minus 1. So from here we can calculate the design thickness, okay, for the material not to be failed under the induced stress. Number 3 is the maximum strain energy theory. Maximum strain energy theory. Okay, actually, when we press a material, okay, then what happens? This mechanical energy for the pressing, okay, the mechanical energy for the pressing is started to store within the material, and if you induce or if you applied more forces or more energy, so the accumulations of the mechanical energy stored increases within the body itself. Now, if you increasing the load of the force, so the material will reach a certain point where further that it cannot store the energy, and due to the accumulated energy it defragmented into some particles or pieces. So this theory for the strain energy incorporate considering that phenomena that the strain energy strain energy is the mechanical energy absorbed by a body or material being stressed within the next slide within the elastic limit within the elastic limit and the failure will occur, material failure, and the failure will occur when the strain energy when the strain energy accumulated in the material accumulated in the material is stressed up to elastic limit. So it will keep accumulating the mechanical energy within the body until it reaches the elastic limit. Beyond that, okay, the deformations will occur. And according to this theory, the yield stress, okay, of the material, it is equal to the 6 plus 10 k to the power 4 whole divided by 2 a square minus 1. Okay, and when we calculate the value of the material thickness, so this is the yield stress. This should be divided by the factor of safety, because we never can allow to the material to be stressed up to its yield stress point. So it should be divided by the suitable factor of safety. Next is the maximum shear stress theory. Maximum shear stress theory. Okay, so this is the tau. the shear is defined as the half of the differences of the major or principal stresses. So the principal stresses is nothing but the sigma theta hoop stress minus radial stresses. So shear is defined by this, and the material will not failure according to this theory if half of sigma theta minus sigma r is equal to half of yield stress. So according to this theory, or after rearranging, we can write the yield stress just a minute. Okay, just a minute. আমি তোমাকে 12টার সময় কল করি, আমার ক্লাস চলছে। তাহলে কি হবে? তুমি 12টায় ফোন করছি তোমাকে। আচ্ছা ঠিক আছে, ঠিক আছে, কোনো আচ্ছা। হ্যালো, হ্যালো।
Yes, sir.
Sorry for that. So the sigma y can be written as twice of k square divided by k square minus 1 into pi. Now you just subtract this sigma theta minus sigma r, so you will get these expressions. Okay, so and suppose this is maximum shear stress tau. Now you see here there is some modifications. Instead of this constant, it is 2. Okay, if we multiply k square by k square minus 1 by a factor √3, then the equation more satisfactorily design the failure of theory. So here, instead of the constant value 2, we can modify it. We can modify the previous equation. We can modify the previous equation by √3 for most satisfactorily result on failure. So we can write that sigma y yield stress is √3 of k square minus 1 into pi. Or from here we can write also. Okay, that's fine. And we can write sigma yield stress by pi equal to root over 3 into k square minus 1. Okay. So, and this represent equation elastic breakdown by maximum shear theory. Elastic breakdown by maximum shear theory. And from here we can write also, that Pi equal to 1 upon root 3 sigma y equal to 1 upon root 3 equal to 0.58 k square minus 1 by k square sigma 1. So this is the few theory of failure. Now if we go back to the maximum principal stress theory, for example, okay, for the example, if we go back, also we look the maximal principal stress theory, then according to theory, the thickness of the thick pressure vessel should obey this equation, or should be calculated based on this equation. Then how to calculate the thickness from here? So it can be calculated. Suppose I am writing again the formula. As for example, uh, so hoop stress at Ri, according to the principal stress theory, it is nothing but Pi or P whatever, R naught square plus Ri square, R naught square minus Ri square. Okay, and these hoop stress value should be less than your permissible stress. The hoop stress generated due to the internal pressure is this, and the hoop stress should be less than the allowable stress. So that's why I am writing less than tau mu sigma allowable. Now we just rearrange it, nothing else. So we can write down r naught square plus ri square divided by r naught square minus ri square equal to maximum value for this should be this one divided by p. From here we can write r naught square by ri square equal to sigma allowable plus p sigma allowable minus p. What is then? That is r naught by ri equal to is nothing but that root over of sigma allowable plus p sigma allowable minus p. And what is r naught? R naught can be written as ri plus t. T is the thickness of the material. So again this is sigma allowable plus P, sigma allowable minus P. Okay, and from here we can get the expression for the T. You just find out the expression for the T. Write down the expression for T thickness. So from here the thickness will be, कोई बताओ, what will be the thickness? Thickness will be Ri, it will be common, sigma allowable plus P, sigma allowable minus P. So according to this theory, for the internal pressure of P and the allowable stress sigma allowable, the thickness will be T, not to failure by this according to this theory. तो ये theory कहते हैं अगर internal pressure P and allowable stress sigma allowable है तो this is the required thickness not to be failure by this theory. Okay, so likewise for the other theory we can calculate the corresponding design thickness not to be material failure. So is it clear? Hello? Hello?
Yes, sir.
तो अगर ये क्लियर है तो we can do a problem. Now if I do a problem, so write down a vessel is to be designed to withstand an internal pressure of 150 meganewton per meter square. It is given that the internal diameter di is given 300 mm and the yield stress of the material that is steel is 450 meganewton per meter square. It is also given. Now calculate the wall thickness, that is the thickness. Calculate the wall thickness required by the various failure theories. Assume or consider factor of safety equal to 1.5. Now you know different theory 1, 2, 3, 4. Okay, 4 theory you know. So to find out the corresponding thickness for the different failure theories. Now do it. Now ये solve करो, कुछ है ही नहीं. Very easy. Now please respond. Roll number 1,
1,
2, 4,
4,
5,
5 present, sir.
6,
6 present, sir. 6
8,
present.
Roll number 8 present, sir.
9,
9, sir.
10.
10, sir.
Solve the problem.
Solve the
11,
problem. 11. Present, sir.
12,
11, sir.
13,
13, sir.
14,
Present, sir.
15,
Sir.
16,
Sir, roll number 16 present, sir.
17,
17, sir.
18,
18 present, sir.
19, 20,
Present, sir. 20 present.
21,
21 present, sir.
22,
22 present, sir.
23,
23, sir.
24,
24 present, sir.
25,
Present, sir.
26, 26, 27, 28,
28 present, sir.
29,
29 present, sir.
26 तो है ही नहीं.
Sir, 28 present.
28 present, 29 present, 30,
Present, sir.
31,
Present, sir.
32,
32 present, sir.
33,
33 present, sir.
34,
34 present, sir.
35,
35, yes, sir.
36,
36, sir.
37,
37 present, sir.
38,
38 present, sir.
39,
30.
40,
40, sir.
41,
41 present, sir.
42,
42 present, sir.
43,
43 present, sir.
44,
44 present, sir.
45,
45.
Keep solving. Relax. 46,
46 present, sir.
47,
47 present, sir.
48,
48, sir.
49,
49 present, sir.
50,
50 present, sir.
51,
Present, sir. 51.
52,
Present, sir.
53,
53 present, sir.
54,
54 present, sir.
55, 56,
56 present, sir.
57,
55 present. 55 present.
57, 58,
58 present, sir.
59, 60, 61,
61 present, sir.
sir.
huh?
61 present.
62, 63,
Present, sir.
63 present, sir.
64, 65,
65 present, sir.
66,
66 present, sir.
67,
67 present, sir.
68, 69,
69 present, sir.
70,
70 present, sir.
71,
71
68
present,
present, sir.
72,
72 present, sir.
73,
73 present, sir.
4,
74 present, sir.
77, 75,
75 present, sir.
76,
76 present, sir.
77,
77 present, sir.
78, 79,
Present, sir.
80,
78 present, sir.
80
80,
present, sir.
माझ्या मार्क
81, 82,
82 present, sir.
83,
83 present, sir.
84,
84 present, sir.
5, 86,
86 present, sir.
87, 88,
88 present, sir.
89,
89 present, sir.
90,
90 present, sir.
91,
91 present, sir.
92,
92 present, sir.
93,
93 present, sir.
94,
94 present, sir.
95,
95 present, sir.
96,
96 present, sir.
97,
97 present, sir.
99,
99 present, sir.
100,
Present, sir. 100.
101, 102,
Present, sir.
103,
103 present, sir.
104,
104 present, sir.
105, 6,
Sir, 106.
107,
107 present, sir.
108,
108 present, sir.
109,
109 present, sir.
110,
110 present, sir.
11,
Present,
12,
sir.
12 present, sir.
113,
13 present, sir.
14,
114, sir.
15,
115 present, sir.
16, Abhinit, 17, Saswat Singh, 118,
118 present, sir.
119,
119 present.
and 49.
Present, sir.
Okay.
Sir, roll number 60 is also present. He is having network issue.
16, 60.
60.
ठीक है. Now tell me the result. What is the thickness according to the principal stress theory? बताओ. What is the required thickness according to the principal stress theory?
63 millimeter.
63 तो नहीं आ रहा है बेटा. देखता हूँ. Okay, you just check your calculation, I think. So according to the maximum you have to write like this: maximum principal stress theory. So according to the equation, okay, according to the equation we can write is equal to internal pressure a square plus 1 a square minus 1. Okay, so here the value is given, yield stress is 450 and it is 1.5. This value is 300. Only unknown is K. So this is 300, it is 300. So 300, 300. So it will be a square plus 1 a square minus 1. Okay. What is the value? Internal pressure is 150, not 300. Who told 300? Internal pressure is 150. You should tell me. So this is 300 by 150. So that is 2. So from here, so k square plus 1 equal to 2k square minus 2. Okay. So k square equal to 3. Okay. And what is the value of the k? K का value बताओ. What is the value of k?
2.
Huh?
1.7.
1.74. Now, what is K? K is nothing but d naught by di. Okay? D naught by di equal to 1.74. So, what is the value of d naught? Di value is given. So, di value is 300 and it is 1.74. So, d naught equal to, बताओ क्या value है? What is the value of d naught? मल्टीप्लाई करो. कैलकुलेटर लेके बैठना इन ईच क्लास. व्हाट इज द वैल्यू ऑफ डी नॉट? What is the value for D naught?
522.
522 mm. And can you find the thickness? D naught minus di by 2. So what is thickness?
109.8.
109.8. 109. So according to this principal stress theory, the material will not fail under the pressure of 150 meganewton per meter square if the thickness equal to 110 millimeter. So this theory tells you the thickness should be 110 millimeter. Similarly, for the other three theories, I have given the expressions. From the expression, you calculate the corresponding theory. Okay. Next day, at the starting of the class, I will ask anybody to show the calculations and the thickness values. Okay? Simple, very simple. You just proceed. Okay. Thank you.